It says graph the solution to the inequality on the number line. And we have the absolute value of y minus 6 is less than or equal to 2. All right, before I get started, right, I'm going to state the rules for an absolute value inequality. And this one is going to be for less than or less than or equal to. Now, if the absolute value of some expression u is less than k, where k is a positive real number, then we can write that as a compound inequality where u is going to be between negative k and positive k. And the same thing applies if we have less than or equal to, such that k is a positive real number. We'll transform that to a compound inequality, but k will be between, u will be between negative k and positive k, which can also include the values of negative k and positive k. In this scenario, we have the absolute value of y minus 6 is less than or equal to 2, and 2 is a positive real number. Therefore, we can transform that into the compound inequality, where the expression of y minus 6 will be in between negative 2 and positive 2. Also, y can be negative 2 or y can be positive 2. We want to solve for y. And to solve for y, we're going to add 6 to every side. I'm going to transition over here. So y is between the values of negative 2 plus 6 is going to be positive 4, and 2 plus 6 is going to be 8. Because we have an equal to under the inequality symbols, they're going to be closed circles. If there were no equal to symbols under my inequality symbol, it will be an open circle. So y will be between 4 and 8. That can also include 4 and include 8. So I'm going to put a closed circle at 4, a closed circle at 8, and I'm going to connect my regions. And that is how I graph the absolute value inequality in this case. So here's the answer to number 21. What I'm going to do is I'm going to do a supplementary problem. I am going to use the same expression inside the absolute value, but I'm going to change the inequality symbol from less than or equal to greater than. So I'm going to switch the signs of direction, and I'm also going to drop the equal to part under it. So you can see how to approach a problem similar in that fashion. Make sure you have this down because I'm going to erase it. Okay, so now we're going to look at the rules when the absolute value is greater than or equal to a positive real number. So if the absolute value of expression u is greater than k, which is a positive real number, then we can transform the inequality into u is greater than k or u is less than negative k. The same rule applies if I have the greater than or equal to, where the absolute value of expression u is greater than or equal to k can be transformed to expression u is going to be greater than or equal to k, or expression u is going to be less than or equal to negative k. So in this supplemental problem, we have the absolute value of y minus 6 is greater than 2. I'm going to transform that into a easier approach using the rules up here. So expression y minus 6 in this case will be greater than 2, or y minus 6 will be less than negative 2. And once again, you take that approach when you have a positive real number. We want to solve for y like we did in the last problem. So what I'm going to do is I'm going to add 6 to both sides. So y is greater than 8. Or, once again, let's add 6 to both sides. Negative 2 plus 6 is going to be positive 4. So y is going to be less than 4. Now, let's graph that on a number line. Y is greater than 8. Because there's no equal to sign under the inequality symbol, that's going to be an open circle. And because it's greater than 8, we're going to go to the right. Shade that to the right. Or y is less than 4. An open circle at positive 4. Because it's less than, we're going to go to the left. And that is how it should look when I have a greater than or equal to sign. Alright guys, that's it for number 21 and the supplement problem to number 21. Hope you guys understand that. Hope it makes sense to you. Take the definitions down, practice your homework, practice your ALEKS. I'll see you soon.